Section 3.4, it's the derivative as a rate of change. In this section, we're going to see different examples where we find the derivative, uh, you know, for different kind of function, and then we see that that's actually rate of change of that function. So this is the limit definition for derivative, which can be used to find out the instantaneous rate of change of any function. Function is changing and you want to find out rate of change of that function at some specific point, exact point. For example, let's say at x0. Here we would like to find out the rate of change of this function at this point, and that can be found by finding the derivative, which can be found by using the limit definition or the formula we discussed in previous section. One example, we can find the velocity of an object if we know the position function of that object. For example, let's say this is the position function, which is a position function, and it's a function of time because the position of that object is changing at each time. So this is the object, it's moving and it's changing its position. Then we can find out the velocity of that object by finding the derivative of this function. Okay, and if you want to find out the speed is nothing but it's just the absolute value of the velocity. Velocity could have direction, it could be positive or negative, but speed should be always positive. And then we can continue that concept of derivative for finding the acceleration. And there is a new term here, jerk, which is also the derivative of acceleration. Okay, so this is second derivative, this is the third derivative. Now we're going to see some examples. The first example is we have given a position function, and this is the position function of a body, and it's moving from time 1 second to 5 seconds. This position is in meters, and then time is in second. We need to answer this three question. First one, find the body's displacement. Displacement means if you have a position function f of t on interval ab, you can find out the displacement meaning it's a change in position, can be found by finding the difference between this value of the function at the endpoint. So this is f of b minus f of a. In this case, b is 5, a is 1. Find out the value of the function when t is 5. If you plug t equal to 5 here, it will be 0, because 25 over 25 minus 5 over 5, that is 0. And f of 1 is, if you put just t equal to 1 here, then you can see that f of 5 is 0 from here, f of 1 is 20. So the displacement is negative 20. That's the displacement. Okay, and to find out the average velocity can be found. Velocity average on any interval ab can be found by using this formula, f of b minus f of a over b minus a. So in this case, it's actually the displacement over the difference between the endpoints, so which is negative 20 from here, f of b minus f of a over b minus a. In this case, it's a 5 minus 1, so it's a negative 20 over 4, which is negative 5 meter per second. So the average velocity on this interval from 1 to 5 is negative 5 meter per second. To answer the part B, which is speed and acceleration, first of all we find the the velocity. The velocity means instantaneous velocity, which can be found by finding the derivative of this function. So let's go here. The function is 25 over t square minus 5 over t, which can be written as 25 t to the power negative 2 minus 5 times t to the power negative 1. And we know the velocity means it's a derivative of the function with respect to time. So by using power rule, we can find out the derivative of the first part minus the derivative of the second part, which is basically, by using power rule, it would be -2 times t to the power -2 -1. If you remember the power rule for the derivative, if you have t to the power n, and if you want to find out the derivative of this function with respect to time, it's n times t to the power n minus 1. So I'm just using n as a -2 here and n as a -1 here. So this -1 comes in front, 5 times -1 times t to the power -1 -1. So the velocity or instantaneous velocity is, if you simplify this, this is negative 25 times 2 is 50. I can bring this negative exponent down here, minus and minus is plus 5 over t squared. So this is the velocity. And now if you go back to the question, it says find the speed and acceleration at the endpoints of the interval. Remember, finding the speed, it's just absolute value of the velocity. We want to find out the speed at the endpoints, so that means what is the value of the speed when t equal to 1 and t equal to 5. You just have to plug the value of t equal 1 here and t equal 5 here and make it positive. That gives you the speed. Okay, so speed when t equal to 1 is absolute value of this function when t is 1, which is negative 50 plus 5 is negative 45, which is 45 meter per second. Okay, and if you want to find out the speed when t equal 5, do the same thing, just plug t equal 5 in that velocity, excuse me. So speed when t equal 5 is equal to the value of the velocity when t equal 5 here. So just put t equal 5 here. That will be negative 50 over 5 cube plus 5 over 5 square. And if you just simplify this, that is what is that? It's negative 50 over 5 times 5 times 5. So just use your calculator. So it will be actually 5 times 5 times 5. So I can cancel 5 times 10, 5 times 2, and it's 2 over 5 plus this one is 5 over 1 over 5. So basically it's negative 1 over 5, because of there is negative 2 and there is positive 1. Eventually it's positive 1 over 5 meter per second. So these are the two speeds at the endpoints when t equal 1 and t equal 5. And we would like to find out the acceleration as well. Acceleration means it's a derivative of this function again. So the second part, acceleration a of t is the derivative of the function v of t. Just use the power rule like this, and derivative of this function would be negative 50 times negative 3 times t to the power negative 4 and negative 5 times negative 2 times t to the power negative 3. I did exactly the way I did here. I just changed t to the power 3 as a t to the power negative 3, and I use the power rule. I did the same thing for t squared. I bring it to the exponent, top, and I wrote it t to the power negative 2, and I use the power rule. So this is the acceleration, which is after simplification 50 times 3 is 150, negative times negative is positive, divided by t to the power 4, negative times negative is positive, so plus 10 over t cube. So if we want to find out the acceleration at the endpoint, we need to find out the value of this function at 5. Just plug t equal 5 here and at 1. So just put t equal to 1 here and simplify. So I'm going to let you do this. Find out the acceleration at t equal to 5 and t equal to 1. Finally, when, if ever, during the interval does the body change direction? So to answer this question, you have to understand the meaning of direction here. So I'm going to show you, uh, look at here. So an object is moving. Let's say this is the path of the object. And now at different point, you can find out the, the velocity of that object by finding the derivative. So velocity, if velocity means, velocity means if object is going to one direction, then the velocity would be either positive or negative. So for example, let's say if the object is going to the right, the velocity is positive, and if object is going to the left, the velocity is negative. For example, I'm just telling you, velocity means, think about car is moving and to the east. So you say a car is moving with a velocity 50 miles per hour uh, towards east. So instead of saying east, you might say positive 50. Positive for east direction, negative for west direction. Same thing applies here. Velocity might have positive and negative value. Okay, so you will be able to find out either the object changes the direction or not if the velocity is going from positive to negative or negative to positive. It has to be, in between them, it has to be zero. So to find out that information, either velocity either an object is changing the direction or not, to answer this question, you need to find out the point or time when the velocity is zero, and you need to find out what happens before that time to that object, what happens in after that time to the object. If the object is changing the direction, that means the velocity would go from negative to positive or positive to negative. Okay, so you should be able to tell uh, this information if you find uh, the point where the velocity of this object would be zero inside this interval. So what we have to do, first of all, find out the velocity, which we already did. This is the velocity, and make it zero and solve for t. And look at here, if anywhere the time is, the any time, the velocity would be zero or not. So to answer this question, so set velocity equal to zero. So from part B, we can find out the velocity this, which is negative 50 over t cubed plus 5 over t squared equals 0. And now try to solve for t, time. So we can make the same denominator. So I'm going to multiply the second part by t, the top and bottom. So that will give us the same denominator. So eventually it would be negative 50 plus 5t equals 0. Now if you try to solve for t, t is 50 over 5, which is 10. But as you can see that this interval we have given is from 1 to 5. So this velocity of this function would only be 0 if the function, the time is 10 seconds, which is, outside the interval. So to answer this question, when, if ever, during the interval does the body change direction, the answer is no. The body does not change the direction because the velocity is never 0 in this interval. If you try to plot the graph of this object, you can see a graph look like this. When t is 1 and when t is 5, when t is 5. Okay, so this is the graph of that object. As you can see that, the position is always positive. It's always going down, but it's not going up now. It's not changing, it's not changing the direction. Okay, this is the graph of an object, and we see that in between 1 to 5, the velocity is never 0. So that's the reason answer is no. Okay, so for example, let's say somewhere in between 1 to 5, if the velocity was 0, Then to answer this question, you try to check what happens to the left of that zero and to the right of that zero. If to the left it's positive and to the right it's negative or vice versa, then you would say, oh yeah, the velocity has changed. It's going from positive to negative or negative to positive. That's why I can say that the object is changing the direction. But it's not the case in this problem. Okay, let's look at another problem. So you throw a rock, and that rock is, the velocity of that rock is 36 meter per second, and this is the height function of that rock, and we need to answer this question. Okay, so let's say, you are standing somewhere on the top of the mountain or somewhere, and you are throwing a rock. So now when you throw the rock, it will follow some kind of path. So you throw it, it will go, in the some path. So this path is actually height of the rock, and this height can be, you know modeled by using this function. So the height of the rock is, position of the rock is 36t minus 0.8 t square. It's given here. Okay, so now after this information we have to answer this question. So how we're going to answer? The first one, find the rock's velocity and acceleration at time t. So this is easy one. Find the derivative of this function. That's the velocity. And then find the acceleration. Acceleration means it's a derivative of this velocity. To find the derivative of this function, just use the power rule. So the first part, the derivative is 36. For the second part, by using the power rule, it would be 1.6 t. So that's the velocity. Acceleration is derivative of this function. The derivative is of 36 is 0. Derivative of 1.6 t is negative 1.6. So this is the velocity and this is the acceleration. If you want to find out the value of this velocity and acceleration at some point, then just replace this time by that particular time. So that's your part A. Okay, let's do part B. Part B is, how long does it take the rock to reach its highest point? Look at here, the rock is traveling on this path, and then after some point it will go somewhere at the highest point. For example, let's say it's going here and then coming down. So this is your highest point. At this highest point, what happens is the rock goes up with some velocity, and at some point the velocity of that rock becomes 0, and that from that point it goes down. So to find out this highest point of the rock, highest point can be found when the velocity of that rock is 0. So you need to find out the velocity. You need to equate this velocity function from part A to 0 and see at what time the velocity would be 0. Okay, so if you just equate this velocity to 0, which is basically 36 minus 16 t equals 0, and solve for t. 36 equals 16t, and just divide both side by, it's not 16, it's 1.6. Okay, it's a 1.6. 1.6. So if you divide both side by 1.6, this is, what is that? Just divide 36 by 1.6, and that will be your answer for the time. So I'm using my calculator to divide 36 by 1.6, and that's giving me 3.6 divided by, sorry, 36 divided by 1.6, it's giving me 22.5. So when time is 22.5 second, 22.5 second, the velocity of this particular function becomes 0, and that is when the that is when the this that is when this the rock would be on the maximum height. Okay, so that's part B. See, how high does the rock go? So we need to find out the maximum maximum height, And as you can see that by solving this part B, you can see that the maximum height would be at time 22.5 seconds. So you just have to find out the height when time is 22.5 seconds. So 22.5 seconds. 22.5 seconds. Okay. Okay. So we need to find out the height function, which is we have given it's 36t minus 0.t 36t minus 0.8 t square. We need to find out the height when time is 22.5. So just replace this t by 22.5 and just do the simplification. So it's a 22.5. Just do this and it will give you the maximum height. We know that when time is 22.5, the velocity would be 0, at which we can get the maximum height. So just do this simplification. So I'm going to do that here on my calculator. So it's a 36 times 22.5 minus 0.8 times 22.5 square. So that is, what is that? No, it's not giving me the right number. So basically it's a point. So 22.5 squared times 0.8. So 36 times 22.5. So that's 405 meter. So the maximum height of that rock is 405 meter. And that can be found by using t equal 22.5. This is 22.5 seconds. So that's part C. For the part D, how long does it take the rock to reach half of its maximum height? So as we know that the maximum height is 405. So now we need to find out how long does it take when the height is half of it. We know that height function is 36t minus 0.8 t square. So when this height function, what is the time when this height is half of this 405? If you try to find this half of 405, it would be 202.5. So now just plug 36t minus 0.8 t square equal 202.5. Now just this is a quadratic equation. We bring everything on the one side and solve for t. If we do that, it would be 0.8 t square minus 36t plus 202.5 equals 0. And we need to solve this quadratic equation to find the answer for this one. So I'm going to do that here. I'm going to multiply both sides by 10 and it will be 8t square minus 360t plus 225 equals 0. Now solve for t. Solve for t and then it will give you the answer. So I'm going to try it here. Okay, to solve this quadratic equation, we can use the quadratic formula. So the quadratic formula is if you have ax squared plus bx plus c equals 0, then x can be found by using this formula, b squared minus 4ac divided by 2a. In our case, it's 8t squared minus 360t plus 2025 equals 0. So that's the quadratic equation. And we want to solve for t here. After plugging a equal 8, b equal negative 360 and c equal 2025, we're going to get, for t we're going to get negative b, negative of negative 360, so eventually it will be positive 360 plus minus square of 360 minus 4 times a times c is 2025 divided by 2 times a, which is 8. If you simplify this, It's going to give you two answers. One is 38.41 second. If you want to, round it to the, you know, uh, two decimal place, and 6.59 seconds. So these are the two answers where uh, the position would be half of the maximum height. So at two time, this object would be at half of the maximum height, and that is possible. There are two times, maybe before it reaches the maximum height, and after it reaches the maximum height at 2 points, the object will be at the half high, uh, as a highest point. So that's the reason we're getting two different answers. Okay, so that's part D. uh, how long is the rock aloft? So to answer this question, uh, as you can see that we have to find out how long this rock will be in the air. So the meaning is, at the beginning the height of this rock is 0, and after some point it will come down again to the ground. So we need to find out the points where the height of this rock would be 0, and by looking that time frame from when to when will be answer this part E. So find out when the height is 0. So this is also solving another quadratic equation. So to answer the last part, so let's see. So to answer the last part one more time, we'll go back here and then make this height equal 0. So that is the height of that rock, which is S of t. We are trying to find out at what time that height is 0. So height in our case, S of t is equal to 0, which is 36t minus 0.8t squared. 36t minus 0.8t squared. So if you factor out t here, it will be 36 minus 0.t2. So by using the zero product property, we can say that either time is 0 or 36 minus 0.8t equals 0. So at the beginning, when time is 0, starting time, the height of that rock would be 0. And by solving this one, which is 36 divided by 0.8, so which is basically, if you divide 36 by 0.8, it would be 45 seconds. So the height of that rock would be 0 at the beginning. So rock starts from here and then goes and come back again at the ground. So from 0 to again 0, this time frame, the rock will be in the air. So this time difference is from 0 to 45 seconds. So the answer to this question is 45 seconds. The difference between these two times is 45 seconds. So for 45 seconds, the rock will be in the air. Okay, so one more problem here. We have given this function, and we want to find out the derivative of this function at different points. So in this question, if you read the question, it says, when a bactericide is added to nutrient broth in which bacteria are growing, so there is something bacteria population, the bacteria population is growing, and now we would like to find out the rate of growth of that population, and this is the population. So B is the population. Find the rate of growth when time is 0, when time is 6, and when time is 12. So you just have to find out the rate of growth of this. Rate of growth meaning the derivative of this function B with respect to time. So I'm going to use the power rule. As you can see that for the first one, this is just a constant. So the derivative of this constant is 0. For the second one, it's a 12 cube times the derivative of t is 1. For the third one, it's a t squared. So 12 squared times 2t. So this is the derivative of this function. and this is called rate of growth. So let's assume that this is new function at t. So we can always name this function as, let's say, growth rate. So growth rate g of t, that's the growth rate, and we would like to find out this growth rate when time is 0. So put t equal to 0 here, that will be 12 cube. So that's the answer for the when time is 0. So growth rate is 12 cube, that many per in first hour. The growth rate when time is 6, at 6 hour, you can find this by 12 cube minus 12 square times 2 times 6. So eventually it's a 12 cube minus it's a 12 cube, which is 0. So the growth rate of that bacteria in 6 hours is 0. Similarly, in 12 hours, you can find out by replacing this t by 12. So it's a 12 cube minus 12 square times 2 times 12, which is basically negative 12 cube, if you simplify that. So these are the growth rate at different time. Okay, so that's the derivative as a rate of change.